Welcome to the last video of this series on binomial theorem and binomial expansion. We will look at this example involving the general term. To recall, for the r plus 1 term, the general term is given by the formula n choose r. We have a, we have b, and the power of b will be the same as the r here, and the power for a will be n minus r. As a good habit, once again, write down a is equals to 2, b is equals to x cubed, and the value of n is equals to 5. So in this case, we will have 5 choose r. We have the value of a 2, the value of b is x cubed. So this will be r here, and the power for a will be 5 minus r. Next, we are asked to find the general term in terms of k here. And once again, write down a is equals to k, b is equals to negative x squared, and n is equals to 6. So for the r plus 1 term, we will have 6 choose r, and a will be k, b will be negative x squared, the power here will be r, and the power here will be 6 minus r. Now, can we simplify this any further? Alright, we can leave it in either this form here or the form given in the answers here. So let's look at the next part of this question. If the coefficient of x power 6 for the first term plus the second term is 60, let's find the value of k. So we need to know the coefficient for the x power 6 term. Just to rewrite the general term for the first part, which is this, the general term for the second part, which is this, and we are looking for the coefficient of x power 6. So for x power 6, this is the only x that we have. So recall, first we have to look for the signs. Then we have to look for the coefficients. And then we have to look for the x term. So in this case, there's no negative sign. So, well, we can simply put a tick here already. We have done this. Which part will be the coefficient? It's actually 5 choose r, 2 power 5 minus r will be the coefficient, because there's no more constant here. And for the x term, we will have x power 3r. So in this case, we want x power 6. So 3r must be equals to 6. And the r will be actually equals to 2. And if we sub in 2 here, we should be able to get the coefficient of x power 6. So the coefficient of x power 6 will be equals to 5 choose 2, 2 to the power of 5 minus 2. And pressing the calculator, we will have 5 choose 2 multiplied by 2 power 3, which will be 80. Now let's try to find the x power 6 term here. So for the sign, okay, we do have a negative here, so just be a bit careful. So we have a negative 1 power r. And next, we have to find the coefficient, which is 6 choose r, k power 6 minus r. So that's the coefficient part. And we have to find the x term. So this will be the one that's giving us the x term. So it will be x to the power of to r. Since we want x power 6, so 2r must be equals to 6 and r will be equals to 3. So let's sub r equals to 3 into here, here, and here. And we will have negative 1 to the power of 3. So we will have a negative sign because it's an odd power. And what will we get? We will have 6 choose 3. That will give us 20. So we will have 20 times k to the power of 6 minus 3, which is 3. So this will be the coefficient of x power 6. So if you're not clear what just happened, all right, I will write it out for you here. What we just did was actually having 6 choose 3, k power 6 minus 3, okay, and there's a negative sign because it's negative 1 to the power of 3. And x is 2 times 3, which is x to the power of 6. So if you work this out, you have negative 20 k power 3. So it is stated in the question that if we add these two up, it is equals to 60. So let's add these two up. We will have 80 plus this equals to 60. So let's shift it around. 20 will be equals to 20k cubed. And it's very obvious that k is equals to 1. Now explain why there is no term involving x power 5 here. So in order to have x power 5, 3r should be equals to 5. And r equals to 5 over 3. For the next term here, 2r equals to 5 because they're asking for x power 5, and r will be equals to 5 over 2. Because r is not a positive whole number, therefore, there is no term that is involving x power 5, as written here. Now let us look at this very last example. The expansion of a minus x multiplied by this, you realize now that the value of n is not given in this question. So our objective is to find the value of a here, the value of n, and the value of p. We are told that after expanding this, we will get these terms here. And let's see how can we find these three variables. So first, of course, we need to write the expansion for this. And we have to expand it until later, once we multiply together, we will get x squared. It is okay to expand a bit more if you are not sure when to stop. Okay, so let's expand this first. So the first term will be 1 power n. So a is equals to 1, b is equals to 2x, and the n will simply equals to n. So we will have n, choose 1, then we write down a, we write down b. So the last power will be the same as this number here. These two should add up to n, so this is n minus 1. So you realize that you don't have to worry about this because 1 to the power of anything is actually just 1. So looking at it, I have not reached x squared yet, so just do it once more. So we will have n choose 2, we put down a, we put down b, and the power is the same as the number here for the last power, and this will be n minus 2, and we will stop here because we do not need any more x power 3. So let's simplify it a little bit. So this will just be 1 because 1 to the power of any value is 1. plus, now what is n choose 1? Now n choose 1 we have learned in the previous video is actually just n. If you're not sure, you just ask yourself, 5 choose 1 is 5. 4 choose 1 is 4. 3 choose 1 is 3. And of course, n choose 1 is n. Now, 1 to the power of anything is just 1. And so we will have multiplied by 2x. Okay, we'll simplify this further later. Now, what about n choose 2? So n choose 2 will be n multiplied by n minus 1 over 2 multiplied by 1. So recall from the previous video again, n choose 2 is actually n multiplied by the next consecutive number. We do it 2 times only, 1 time, 2 times. And for the denominator, it will be 2 multiplied by the next consecutive number, which is 1. So we do it 2 times also. In case you do not remember, so for example, 7 choose 2 is actually equals to 7 multiplied by 6 over 2 multiplied by 1. So we will multiply the consecutive number but only need to do it twice. So 1 time, 2 times. So we start from 7 at the numerator. We start at 2 at the denominator. We also do it twice. 1 time, 2 times. Here 1 power n minus 2 is simply 1. So we can ignore. And here we will have 4x squared. Simplifying this one last time, we will have 1 plus 2nx. Okay, the x term will always be the last. Plus, so here we will have 4 over 2. So this will give us 2 later. So we will have 2n minus 1 x squared. So we will just stop simplifying at this point. And we are told to multiply these terms here with a minus x. So let's do that now. So a minus x multiplied by 1 plus 2x to the power of n is simply a minus x multiplied by these new terms that we have just expanded. Just to look at the question again, they told us that if we expand this, the first 3 terms will be here. So let's expand this first. We will get a. Okay, let's be a bit systematic. So we will look for all the constant first. And this is the only one that will give us constant. Next, let's do it for the x term. So this will give us the x term. So we have 2anx. This will also give us the x term. So minus x. Of course, next we will look for the x squared term. So this will give us the x squared term. So we will have 2a and n minus 1 x squared. And this will also give us the x squared term. So we'll have minus 2nx squared. Now let's compare the coefficients and the constants. So first we can have a is equals to 5, which will make life much easier later. We will also have 2an minus 1 will be equals to 69. Since we know that a is equals to 5, so 2 times 5 is 10. So 10n is equals to 70 and n equals to 7. So we have already found 2 variables. Now let's look for the last one, which is p. Okay, so let's compare coefficient of x squared. So we will have 2an multiplied by n minus 1 minus 2n. So these are the coefficient of x squared. And the coefficient of x squared here is actually p. So this must be equals to p. If we sub in the value of a, which is 5, and the value of n, which is 7, we will definitely get the value of p. So 2 multiplied by 5, so this is 10, okay? Later we'll multiply by 7, we'll multiply by 7 minus 1, which is 6, minus away 14 here because it's 2 times 7. We will get p. So work this out. 10 multiplied by 42 will be 420. Minus away 14, that will give us p. And 420 minus 14 is 406. Now see if you can work out the next similar question on your own. And you should be getting this answer here. And this concludes the chapter of binomial theorem.